Welcome to part 2 of our 4-part series on economic modeling. In this video you will learn 3 important skills. The first involves solving for reduced form demand and supply equations. The second involves deriving inverse supply and demand equations, while the third teaches you how to graph inverse equations. Recall the supply and demand equations from part 1 of the series. The equation in the upper left represents the demand for beef, which contains 3 variables. It specifies that the quantity demanded of beef is a function of 2 independent variables, the price of beef and the price of pork. The equation in the upper right specifies that the quantity supplied of beef is a function of only one variable, the price of beef. However, remember from principles of micro that we graph demand and supply in 2 dimensions, the price and the quantity demanded of beef. Therefore, our first skill is to reduce the equations to a function of only 2 variables, price and quantity. We accomplish this by substituting into the demand equation an arbitrary value for the price of pork. Suppose the price of pork is $3. After the substitution, we arrive at the following demand relationship. After multiplying through and collecting like terms, we arrive at the following final reduced form demand equation. Notice that it now contains only 2 variables, the quantity demanded of beef and the price of beef. The effect of changes in pork prices are absorbed into the y-intercept. Before it was 82 and now it is 85. When the price of pork changes, the demand curve shifts to a new y-intercept. This insight will become important in part 4 of the series. The form of this equation should be familiar to you from your algebra classes. It is a linear equation of the following form. In our case, the slope m is equal to -3, while the y-intercept b is equal to 85. The slope of the equation is important in economics. We expect the quantity demanded of beef to change by 3 units for every 1 unit change in the price of beef, all else constant. In this case, the all else constant refers to keeping the price of pork fixed at $3 per unit. In the case of the supply equation, our task is already complete. It is in the reduced form, given that it is a function of the 2 important variables, the quantity supplied of beef and the price of beef. As with the demand equation, the slope has an important economic meaning. We now turn our attention to the second skill. We begin the second skill by recalling the reduced form supply and demand equations from the previous slide. The issue is that the equations are written with quantity as the dependent variable and price as the independent. However, in principles of microeconomics, we learn to draw demand and supply equations with price as the dependent variable and quantity as the independent. Therefore, our task is to invert the curves so that we can graph them consistent with the principles of microeconomics. We do this by moving the price to the left and quantity to the right and arrive at the following equation. After dividing through by 3, we arrive at the following inverse demand equation. Another important outcome of finding the inverse curves is that the y-intercept now has economic meaning. It is the price that makes quantity demanded equal to 0. We call this intercept the consumer's reservation price. It tells us that the price of beef must fall below this price before consumers will enter the beef market. Remember, everything has substitutes, and in this case, we expect consumers to substitute pork if the price of beef reaches this level. However, notice as the price of beef falls below this level, the quantity demanded of beef begins to increase. Now let us turn our attention to the supply equation in the upper right. If we repeat the process, we have the following relationship. After dividing through by 15, we obtain the following inverse supply equation. As with the demand equation, the y-intercept of the inverse supply equation has an important economic interpretation. The 0.33 represents the reservation price of the producer. It indicates that when the price of beef falls to this level, producers will exit the market and quantity supplied will equal 0. It is equally important to remember that producers have other opportunities as well. The resources used to produce beef can be used to produce other commodities such as pork. The producer's reservation price indicates the minimum price needed by producers to bring beef to the market. At this point, we can use the reservation prices to argue that the price of beef must be below $28.33 but above 33 cents before a market for beef will exist. In summary, we now have two sets of equations. The first are the reduced form equations where the quantity is a function of price. The second are the inverse equations where price is a function of quantity. We now turn our attention to the third and final skill, graphing the inverse supply and demand equations. We begin the process with a two-dimensional space with price on the x-axis and quantity on the, with price on the y-axis and quantity on the x. This should be familiar to you from principles of microeconomics. Let us graph the inverse demand curve first. The curve is a linear curve with y-intercept of 28.33 and a constant slope of negative 0.33. The curve appears as follows. Notice that we indicate in parentheses that the price of pork is held fixed at $3. This reminds us that the position of the curve in the XY space is determined by the price of pork. Now let us graph the inverse supply curve. It is linear with a y-intercept of 0.33 and a positive slope of 0.07. The curve appears as follows. Remember from your principles of microeconomics that the point of intersection of the supply and demand curves plays an important role in the stability of the model. It indicates the point where the model has no tendency to change. Only one price and one quantity are consistent with the point of intersection. As we shall see throughout the semester, equilibrium points in economic models are very important. If we draw a horizontal line from the intercept to the y-axis, we have identified the equilibrium price. This is the only price that makes quantity demanded by consumers equal to the quantity supplied by producer. It clears the market, resulting in an absence of surpluses or shortages. If we draw a vertical line from the point of intersection to the x-axis, we've identified the equilibrium quantity, where quantity demanded equals quantity supplied. This concludes our part 2 of the series. In part 3, we will explore the equilibrium of supply and demand models in detail.